Hello, this is Group 5. We'll be doing part 1 of the review video. My name is Edgar Villanueva. I'm a math major here at Citrus College and I plan to transfer to Cal Poly tomorrow.
Hi, my name is Trisha Taylor. I'm a bio major here at Citrus College, transferring in the spring to University of Irvine.
Hi, I'm Angela Watkins, a civil engineering major, and I'm going to be transferring to Cal Poly Pomona.
The question states, an object of mass m starting from rest at point A, as shown in the figure drawn, is pushed by a horizontal applied force of magnitude F on a horizontal tabletop, which is distance h above the floor. The tabletop has a coefficient of friction UK. When the object reaches the end of the table, point B, it collides with an identical object. The two objects stick together and are launched horizontally off the table, following the trajectory shown in the figure drawn. Strike the floor at point D. Air resistance is negligible in this entire problem.
So the first thing that we're going to look at for this FPD is our mass 1 here. It can also be called object A. So with this object, the vertical components are going to be balanced, so we're going to draw the lengths at the same length. So I'm going to go ahead and draw that. So starting from the center, we're going to draw a normal force 5 inches from the center. So that's our N1. And then for our other vertical component, that's going to be our force of gravity, and that's also going to be 5 inches from the center, since this is balanced. So that's M1G. So for our horizontal components, the force of friction is going to be shorter than our applied force. So I'm going to go ahead and draw that at 3 inches from the center. That's our force of friction, and then our applied force is going to be 6 inches from the center. It's applied force. Now Edgar's going to talk about the object B.
Okay, so now I'm going to go ahead and break down object B. As stated in the given, mass 1 equals mass 2. For now, we're just going to separate it as mass 2, just as a general rule. As Angela mentioned, when you're breaking down the objects and you're breaking down the vectors, you have to start at the center. Because mass 1 is equal to mass 2, and it's not moving up or down, I know that the force of gravity is going to be the same. So if it was 5 inches here, it must also be 5 inches here. So we're going to take our ruler, go down 5 inches, just like on this side. This will be our M2G. And because it's not moving up or down, the forces are balanced. So your normal force will be the same as your force of gravity. So you have your N2. Okay, now we're done with object B. There is no more forces acting upon object B because it is at rest. Therefore, now the last thing we're going to do is choose the directions. We know that object A is moving to the left, so we're going to choose that as a positive direction. And because neither one of them is moving up or down at this moment, we're going to choose up as a positive direction. Okay? And now notice that we didn't have to resolve anything for object A because the force applied, as you can see on the X and Y direction over here, it is going straight horizontally. But if you had an applied force that was at any other angle, you would have to resolve that force first to figure out what would be your force on the horizontal. There you go. This is how you would set up the problem. On behalf of everyone here, Group 5, Edgar, Trish, and Angela.
Thank you for watching, and we hope you found this video helpful, and happy holidays from Group 5.
Happy holidays. Thank you.